2010 Volkswagen Routan, if I'm saying that right. It's got the 3.8 liter V6. Basically, this is a Chrysler vehicle because it's got a Chrysler engine, a 62 with a TRE transmission in it, transaxle. Yeah, looks like a Chrysler product. It's got even the Chrysler key fob right there. But it's got a Volkswagen badges on it. So, key on, engine off, VCMI hooked up, Evan's helping. Full system scan. Customer complaint is he's got in the engine computer, which is part of the TCM PCM's one computer, overdrive solenoid circuit, control circuit, overdrive hydraulic pressure test. So if this was active, it went to stored. He says it gets worse if you drive it, 10 miles or so when it gets warmed up. So what we're going to do is we're going to do some checks on it. And I printed the schematics off. So what I'm looking at here is, here's the module, the PCM, TCM. Here's the transmission assembly solenoids and transmission range sensor. This is the circuit overdrive control. And then over here is the overdrive pressure signal. So this one and this one is this one and this one. Now is this one going off because it can't do the control circuit? Just think focus. Anyway, so 12 volts feed these solenoids. The computer controls it, grounds it. Through a MOSFET transistor, turns it on and off. The pressure switch and the overdrive solenoid circuit. Looking at tech data or service data. So we're going to look at next to troubleshoot this. This is the same schematic. This right here, this is the, let me show you right here. Let me look. All right, so again, if you look at this, the solenoid assembly, pin 19 is right there. Pin 11 is right there. We're going to check and probe there. We're going to do a couple different checks. That's on the transmission range sensor or transmission solenoid / range sensor assembly. And then the PCM side connector C4, pin 1 and 22, 1 and 22. Again, 12 volts comes and feeds all these. And it feeds them all from, let me find a schematic here that shows that. Oh, it's right on the same one I'm looking at. Sorry. 12 volts DC comes in here, feeds all these. And then the computer grounds it. Now on the other side of the circuit, there's a 5 volt supply fed from the computer. That's for the transmission range sensor and the temp sensor. We don't care about that right now because that's not an issue. But if one of these solenoids is bad in here, you have to replace this whole entire assembly, the whole transmission range sensor, which involves, grab a light here, removing all the stuff on the top here, putting on the lift, moving this connector, moving this cover. You drain some fluid out. You got to remove the hull, valve body, and the solenoid pack. Take it on the bench, remove and replace the solenoid pack, put it all back together. Place some gaskets, O-rings, and some sealant. But anyways, this is the connector we're talking about right there. Is the one we're going to get at. So what we're going to do, a couple of checks is, we're going to see, if it acts up when it's cold, if it acts up when it's warm, see what's going on. But we want to check the wire integrity from here to here. Make sure there's no opens on these, no short to powers, no short to grounds. We can hook a scope up or a meter up on the control side. Control with the scan tool. We can check resistance across these solenoids from pin 10 to 19, 10 to 11, and we can compare them to like compare them to pin 10 and 7, especially have continuity across those solenoids. So let me get all that set up and we'll go from there. All right, so what we're going to do first is compare this to a good one. So what I got here, we got this circuit that's throwing a fault, like I said, and this one that's throwing a fault. So the overdrive control and the overdrive pressure signal. So right now I'm in the UD, I guess, I don't know if that's up drive or what it is, control. Pin 7, which is right there. And I'm probed into it right there, back probe. My other lead on the ground. I got my VCMI hooked up, engine running, and I got my split screen going on. So right now I'm in active tests. But if you look, there's 0 and there's 20 volts. I'm at even though if you were to measure that, you would be at, 14 volts, right? That's the alternator voltage. Those little signals in there that come up, I'm not controlling nothing. That's an inductive spike because it's a magnetic field going to 50, 60 volts, not 50 volts. What that is that's the computer doing its self-test on these solenoids. If you look in the service data, it tells you it does self-test. It checks for an inductive spike. If you look up the code, it'll tell you in the service data. Watch out, buddy. Yeah, you have voltage, battery voltage going up. Always voltage up to the point of ground. The computer controls the ground. Well, if you look, those inductive spikes, it tells you in the service data for that code that it's doing its self-checks. And that's a good solenoid. Now, if I go to up UD solenoid control, so you can see the spikes, right? It'll come up again. That's its computer doing its self-test. If I go to up drive control, this is a good one. I don't need data stream because I'm scoping it. I'm going to hit F1. And it's going to toggle it for just a little bit. There's your square wave. Then it's going to go away. So I'm going to stop that. Hit escape. And go back. I just make this scope bigger here. I'm going to zoom in. Trying to do this one-handed. That's your square wave, your duty cycle, on, off, on, off. So you're going from, I'm just, 14, 15 volts down to, your 0, which is on time. Off time, on time. You can do a duty cycle measurement if you wanted to, blah, 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 right? So we don't need all that. Anyways, now nothing's controlling it. We're playing again. We should have our inductive spikes. There's one. Should be another one coming up. And it's doing its self-checks. So this is a good one. There's another one, and it tells you on the service data. So now what I'm going to do now is I'm going to go and check the one that's supposedly bad, because we just did this one just to have a reference. And we're going to check this one next. All right, so now what I did is I back probed on pin 19 right there. Everything's off, so we have 0 volts. So I'm going to do now, because we have the key off, plug my VCMI back in so we can do bi-directional controls here. I turn key on engine off while I watch the scope. It'll jump up. Jumped up to 12 volts. Sorry I hit the horn there. Scared Evan. Alright, so if you can see, it's doing its self-test. Right? So now let's do our split screen. Well, but you gotta move. Get out of under the table. Come on. We're going to do our split screen now. Oscilloscope. So there's our alternator voltage, our self-test. We're going to do overdrive solenoid. No live data. We're going to hit F1. And you should have that. There's nothing. There's your test. But look, I'm turning it on. Isn't doing nothing. Let me do it again. Solenoid control. It's going to do its self-checks. I don't want no live data. I'm going to hit F1. It looks like it tried to do something there. Maybe not. But it's not doing its test like we showed, where it's going to 0 volts in that square wave. So, we can check the output of the computer with the test light to battery positive and check it and make sure the light flickers on and off, turns on and off. We can check the wiring. We can check the resistance across the solenoids and go from there. Alright, so what we could do is take a test, like I said, go to battery positive and check it at that connector and turn it on. We should make sure the computer's controlling it, which it is somewhat. Well, it has to be, because this inductive spike means the computer is turning its MOSFET transistor on. Moving on with that, this overdrive pressure signal, we could do the same test, but there's no bi-directional controls in here, because to turn a switch on, you have to have fluid pressure going to it, which I believe is related to this, because if the overdrive solenoid's not working, you're never going to get pressure to turn this one on. So if we fix this one, it'll fix this one. So now what we can do is check continuity from the, the solenoids themselves and go from there. Alright, so what we're doing now is we're going to check the resistance of these circuits. So we're going to go from the power wire pin 10 to 7 because that's a known good one. On here, we got them probed out, our VCMI hooked up, and if you look, we got 1.4, 1.5 ohms, which is good. Now we're going to go 10 to 19 and see what we get. Alrighty, so we went 10 to 19. The VCMI, we're still getting 1.5 ohms, right? And we can do Ohm's law and check all that, or 10 to 19 right there. Now, granted, it's cooler in here and we haven't ran it a lot. So when it runs, like he said, after 10 miles, it gets worse. We need to check it when it's good and warm. Maybe the resistance is changing, it's causing those issues. So we're going to do some other checks here and check the wire integrity and go from there next. Alright, so what we're going to do now is we're going to check for a voltage drop. So we're on pin 10 with one of my leads from my oscilloscope, the red lead. And that's your power coming in. And pin 7, which is the updrive UD control, which is the internal ground coming from the PCM. That's a good one. Got the VCMI hooked up. T-pin back there. And right now we're going to read 0 because we're comparing differential from here to there. And when I hit updrive solenoid, there's your self checks that it's automatically doing. When I hit the updrive, I'm going to turn it on for 1 second. You can see the pulse width modulation there and it turns off. Now we're going to check it and compare it to the bad one. Alright, so now we got our red lead to 10 again, power coming in, and our black lead to 19, which is the bad one. Still VCMI hooked up, probe. And we're going to go to overdrive solenoid. There's the self checks, no data. I'm going to turn it on here when it gets to the next screen so we can see it. I'm going to turn it on. Nothing changes. Well, it did a little bit, tried to, right there. Let's do it again. Overdrive solenoid, no. Turn it on. Did a little bit right there, but not enough to hold it. All right, so what we're going to do now is we're going to take a test light to battery positive and check pin 19, which is the bad one, and check pin 7, which is a good one. See what it acts up as. See what it does. So the top one in this case is the good one. The top pin right there is the good one. So we're going to go to overdrive. He's going to turn it on. Once it turns on, you can see it cycling. That's the good one. And now we're going to go to the bad one. And 1 second. Hang on, let me go to the bottom when we get positioned here. Okay, so on the bottom one, you go so he's got to go to the, go ahead, turn it on. No flicker. Yeah, run the overdrive one. Flicker at the very end right there because it, well, did it self-test at work. Now what we're going to do is we're going to switch these wires around and see if it moves or follows it. All right, so we had to grab another scan tool, laptop with an old scope because the other one, got to charge it. But what we did here is we took, this is this assembly transmission, the connector down there. All we did is we took pin 19 and we swapped it to 7 because that's a good one. We moved 19 to 7 and 7 to 19 down there. So what we're going to do now is we're going to take, so the one on the bottom there, well, first let me show you my test light. I got my test light to battery positive. And the other end here, my hand is negative. Test lights up. The one on the bottom there, the very bottom pin was, let me show you here. The very bottom pin was the bad one. And the top one was the good one. But now we switched them. So again, the bottom pin there was the one on the bottom of the screen was originally the bad one, and the top one was the good one, but now we switched them. So now the one on the bottom is the good one, and the one on the top is the bad one. So if you watch this, if I go over into my solenoids here and turn these things on, I'm going to turn this thing on here, my test light, once I hit F1 to turn it on, it'll light. And it's pulsing, and it'll shut off, which it never did that before on that one. Because, let me do it again here. It never did that before because that one was bad. So now I'm going to move it to the top one next. All right, so now I moved it to the top one, which before was the good one, but now it's the bad one. Same test. It should light, however, it does not. Sometimes at the very end it will. And it's not lighting at all. Well, it did a little bit at the end, it looked like. Because that's its self-test, which is just like before. Let me try it again here. Yep, it did at the very end. Let me do it again just to show you on camera. I'll zoom in. Now before, again, this top one was the good one, but now it's the bad one. What does that prove? Well, we believe that the solenoids are good inside this transmission, and it's a computer or wiring ground control issue. I'm going to do it again. It didn't do it there, but sometimes you'll get it at the very end where it'll flicker when it does its test. There, it did it. It just flickered at the very end. So that proves that the solenoids are good, and we got to go after wiring and computer, perhaps. Alrighty, so what we're going to do now is we're going to check the wiring. Just got to find my diagram right here. We got the PCM connector disconnected, pin 1, C4. And then the transmission connector, pin 19. We're going to check continuity to that and short to ground, which it won't be short to ground because if it was, it'd always be on. Or short to voltage, it'd always have high voltage. We're just going to check for high resistance for the bad circuit. Engine computer on this one's down there. The C4 is the last connector up there. That's the transmission control. This is a Chrysler computer. So we got the connector off right there, and we got it probed out for pin 1 hooked up to my DMM. We're going up there. And we have a good circuit. So there is no... I mean, we can check at the short to ground real quick. Put on the highest reading for that. It's not going to be shorted. Nothing there. Because if it was, it would close the circuit all the time. Check at the chassis ground too. So we'll check the next one and go from there. All right, now we're going to check the other one because we don't have a good one. Well, the other wire's good, but 2 to 7. So we're down there in 2 to 7 up here. We got 0 ohms, so that's a good wire. Obviously, nothing's going to be shorted. Just to prove that, I always put on the high scale when you check for shorts to grounds. And touch there, nothing. We'll move on from there. All right, so after all those checks, one thing we can really check now is power and grounds. Going to the actual engine computer, ECM, and if those are all good, which we'll do. I don't know if I'll show that on film or not, but if those are all good, it's going to need a new computer because it's not controlling the ground on that one circuit. It's trying to, but it's not. And the big proof was, well, we had good resistance on the solenoids, right? Which, by the way, we checked all the other solenoids. I know I didn't show it on video. We got 1.3, 1.4, 1.5 ohms. The pressure switches are 300 ohms. There's one other solenoid that's 5 to 6 ohms. So they all check out according to the schematics. That's good. The fluid's good. All that stuff's good. So, and like I said, the big proof, you know, I got to take resistance with a grain of salt, but they check good. But we never had control with the test light on the one wire, on the pin 19 wire. And then we swapped it. It stayed with that same wire, which proves that the other solenoid that could suspect to be bad is actually good. So, like I said, it's a computer side issue. That's why we check the resistance. Make sure there's no shorts to power or grounds from the computer to the solenoid pack. All that's good. So what we're gonna have to do now, this will probably be part one of this video. We're gonna have to find a computer, a new one. You can even get a used one. I know this is a Volkswagen, but you can get one off of Chrysler Town & Country. As long as you have the same base part number, we can write the VIN, write the odometer, flash it to the newest software. We're gonna have to pull a pin to transfer the secret key data and get all that information. So that'll be it for this part one for this 2010 Volkswagen, well, I'm not sure I'm saying it right, Routan, which is the same thing as a 2010 Chrysler Town & Country. So that is it for this video. All right, so we got a new computer. This one right here is the old one. The base part number, we want to make sure it matches. The end part, the last 2 digits for the software level. You can program that using YTech 2.0 or the Legacy app. I'll just show you some of the programming here. I'm not going to show you everything. If you want to learn how to do all that, you got to go to Keith Perkins L1training.com website. It goes over all the stuff. So I put the new, well, it's the salvage one in. We verified everything on it that it's good. So that's where the computer sits, under the fender well there. Pull the wheel off, pull the inner lining out, and we swap that. So now what we're going to do, put all this back together. We'll write the VIN, transfer the secret key data, write the odometer, and then give it the newest software update, and go from there. All right, so I got the new computer in. Everything's back together. Wheel wells back in, tires back in, torque down. Now I'm gonna use between the IM508 and the Autel Ultra, I'm gonna program all this stuff. So what I'm gonna do first is I'm gonna hook up the IM508 because I got to get the 4-digit pin so I can type in the scan tool a pin to let me replace the PCM, transfer the secret key data, and all that stuff. So let me hook up the IM508 next. All right, so key on, engine off. This is IM508 boot up. What we're going to do here, sorry about the glare again. I'm going to go to mobilizer. I can auto detect the van, but I'm going to go to Chrysler, even though it's a VW, but it's a Chrysler product for this van anyways. I'm going to go manual selection. It's going to be a 2010 North America Town & Country 2010 5x key, slot key. All I'm trying to do is pull the pin. So it's turned on. Go to control unit. Read password. Should be a 4-digit password. There it is, 4956. So that's our password. So I'm going to do now. So I'm going to exit out. I'm going to auto detect it now. So I can write the VIN. So 4956, I can use this one to write the VIN and all that stuff. Transfer secret key data, or I can use the Autel Ultra. I guess it really don't matter for this one. But you can't pull the pin with the Ultra. You have to pull the pin with the IM series, as far as I know. So go to control unit, PCM replaced. Yeah, read all that stuff. Yep, don't screw it up. 4956. Okay, make sure it's correct. You only get like 3 chances. I'm not sure after that if it locks it off you can reset it or not. So current VIN in the wireless control module is 6564, which we never replaced the WIN. 6564, because the WIN's in the steering column here. we just replaced the PCM. So we hit OK. So it's writing the VIN to the PCM and eventually transfer the secret key data over. Because we're doing PCM replace. Transfer and secret key successful. Cycle ignition off before starting the vehicle. So we're going to turn it off, turn it back on, hit OK. So what do we do there? We transfer the secret key data from the SCAM or WIN module to the PCM, and we wrote the PCM, or we wrote the VIN from the car into the PCM in that step. So what we're going to do now is we're going to start to make sure it runs. And then what we're going to do is hook up the Ultra, rate the odometer, do some software updates, cam crank relearns, and make sure it's all good to go. Let me start here, see if it starts. Starts right up. But we do got the other software on here, so we got to write that, which we're going to do next. So, the only thing that's on is change oil, seatbelt light, all that stuff. So I'm going to hook up the Ultra next. Alright, so we got the Ultra hooked up. VCMI plugged in, key on, engine off. Gonna auto ID this. Now to pull up the right VIN. Sorry about this bad glare. Yep, 6564. We'd never programmed the VIN in there, would have pulled up the other VIN. But we already did that with the IM508. Hit OK. What we're going to do is we're going to do a full system scan, check some stuff, write the odometer, do all that stuff. So we'll let that scan right now. All right, it's almost done. Go to report. And the only codes we have in here, HVAC don't care about. Lost comment to ECM is a stored code from the WCM. We'll clear all that. We had stuff unplugged and we're transferring computers and all that as well. And then what we'll do is we'll go into the ECM and we will take note of some stuff. We'll look at the mode 9 data. So ECU mode 9 data. Make sure the VIN changed. Yes, so original VIN, this is the used computer. Salvage one we put in, this is the one we're in there right now for the vehicle, 6564. So you can tell if somebody changed the computer. So obviously that was the one from the salvage yard one, that's the one we just wrote. Let me see here. So this is the number we want to watch right here, because this is a software version we're going to go to. We're going to flash it to that. Or, not going to flash it to that, we're going to, unless it already is flashed to that, which it may be. We'll have to take a look here. We'll take a look and see if that's already flashed to it. If not, we'll flash it to it looking at our J2534 Chrysler pass-through document. So look at that. We're going to go to special function. We'll do the cam crank relearn. So check PCM odometer. Is odometer reading between 32.8, 328.734 and 838? No, that's a lot of miles. It's at 127.283. So I hit no. I'm going to do miles. We're going to type this in. 127.283. 127.283. Let's make sure that's correct. 127.283. So we're going to write the mileage in there. Yes, enter, okay. It's not going to change your odometer, it's going to change the mileage in the computer. The one we just replaced. The one we just replaced under that. It's resetting the ECU, you can hear it. So it's completed. So that's good. We can check the van. We already know that stuff's good. We'll do some of the stuff later. But now let me look and see if it actually needs some software update. All right, so I pulled up this document. The part number in the use module we have is this one right here, which is this one right here. That's old software, new software. This is showing a 2010 RT, whatever RT is, 3.8, 50S, Town and Country, right? That's what's in there right now. But this part number is the one that came off our old computer. So I'm going to hit this and hit enter. I'm going to search for that one. There's only one in there. No, there's going to be a couple. So let me find the right one again. So yeah, this one right here, 2010 05150252AD. That's the old part number from our old computer, which is this one right there. That's our old computer, which is that. So the software that it needs to go to is that. Now the software that's in here, which is, let me see if it's in here, 680, 494. It's not even in here. So when they did a flash on this one from the, who knows what they flashed, right? Well, I'm sure it's been flashed correctly. It's just that it's a module it's from a salvage yard, right? So it's used. So what we're going to do is we're going to write this software number in here into the used computer that's in there, because that's the right vehicle, because this vehicle will have the newest software. And get rid of that. How we can do that, there's a special procedure. Like I said, if you want to know how to do all that, go to KeithPerkinsL1Training.com. It's got awesome videos on it. You'll learn all about programming and all that stuff. So let me get some more stuff set up next. All right, so I found the software for it. You have to pay a fee to get into this. Here's the new software number we want, 2010 3.8 PCM, use in VW only, automatic 50 state PCM. So that's the one we're going to download and flash to this car. So it's got the newest software. Like I said, if you want to learn how to do all this stuff, this is programming, you need to subscribe to KeithPerkinsL1Training.com. We're going to do some special procedures here next. All right, so I got my key on engine off on the van, battery power supply hooked up, 13.7 volts. You got to have this, otherwise, you know, you can cause issues, right? So you want to turn everything off. Turn the fans off. Got my VCMI hooked up. Got the files transferred, written correctly. Like I said, go to KeithPerkinsL1Training.com. Keith Perkins is the guy. It's L1Training.com. I'll show you how to do all these. So we have to do a special mod to this file. And there's certain places you got to put on the computer. So we're going to go into YTech 2.0. And we're going to pull it up. We're going to go Legacy app. I'm going to select your VCMI and hit start. It'll connect to the VCMI here. That should turn on in a minute. The top light there. Once that thing wakes up, there it is, turned on. You heard it. It says, do you want to update the engine computer to this part number? Well, yes, because that's the newest one for this Volkswagen. So we're going to hit yes. Starting flash process. Make sure you maintain battery voltage. So it's going to go through its process right now. It's flashing controller. I'll pause it through this video. So it's erasing the logical block right now. Now it's doing its flashing, so I'll pause it, unpause it, come back while this bar goes across. All right, it's continuing the flash. Let it go some more. Again, what this is doing is putting the newest software on this computer for this vehicle. After that, we do cam crank relearn. We'll do some other checks, show you guys some other stuff. We'll check fluid because, well, we already checked it, but on this dipstick here, it's not a dipstick, it's a little plug like this long. You got to have a special dipstick and a scan tool to read it to get you within the chart to get the right level. So, continuing the flash here. All right, it's almost done with this part anyways. So it says, please turn the ignition off. Turn it off. Hit OK. It's going to probably tell us to turn it on. It's doing its checksum verification. It should tell us to turn it on. Yeah, please turn on the ignition key. Not running, just on. Okay. Hit OK. Good to go. Flash process completed successfully. So we updated with the new software. Now what we'll do is we'll make sure it starts. We'll hook up our Ultra back up, make sure the newest software is written in there, and do some of our other follow-on maintenance. All right, so I unhooked all that stuff. I got a VCMI hooked up. Let's make sure it, starts. Which it does. So, we do now, we'll go to my history. We'll make sure that software was written correctly. Or not written, well, it's going to be written correctly, but I mean, that it updated correctly, I guess would be the words. So let me pull this up next. All right, so there's one code in the central gateway. It's stored. I'm going to clear it. You'll get U codes once in a while, like this one, because when you're programming modules come on and offline, so that's expected. So now we're going to go into the control unit, PCM, ECM. The software I believe ended in, well, let's look here. Yeah, right there, ECU. So it should be 680-62712AF, 680-62712AF. And then our VIN's still correct, so everything's good. So now what we're going to do, we're going to do a cam crank. We don't have to. We're going to do a cam crank relearn, learn electronic throttle control. We're just going to do all that stuff real quick. Just make sure everything is good to go. And I want to show you one other thing on this before we wrap this up. Alrighty, so we'll see if it's warmed up enough to do these other follow-on maintenance. So I'm going to turn key off. Turn the engine off, key on, engine off. Cam crank relearn. Okay. Please start the engine. Yeah, it's got to be above 158 degrees. So we're not even there yet. Let's just see where we're at. We got to warm it up some more. It's like 6 in the morning. It started like 5 in the morning doing this, so it's pretty cool outside. Yeah, we're 145. We got about 9-10 more degrees to go. So let it warm up some more. Alright, so we're at 163-ish. So go back to special function. Turn the engine off. Key on engine off. Cam crank relearn. Okay. Start the engine. Cam crank relearn in progress. Still in progress. Still doing its thing. Let me pause it for now until it's done. All right, it's finally done, completed. So we'll hit OK. Now we're gonna do, turn it off, key on engine off. I'll learn the electronic throttle control. So the engine's not running, key on engine off. Press and hold the accelerator down to the floor. So I'm holding it strongly to the floor, hit OK. Release the accelerator. Do not touch the accelerator. Resetting the ECU. Learn electronic throttle control pass. So hit OK. Start up again. So we can reset all of our counters and stuff there if we want to do that, but I just wanted to show you one other thing before we wrap this video up. Alright, so we're doing one more full system scan. Everything so far is passed. And what we're going to have to do now is we're going to check tranny fluid again, make sure it's topped off, make sure the fluid's clean, red in color, you know, all that good stuff with the special dipstick and the scan tool. I've got another video that shows that. I don't know if I showed on this one or not. And then one other thing I did want to show, however, is in the engine computer, tranny computer. If you go to active test like we did in the earlier part of this video, or if it might be part one of the video, I'm not sure I'm going to upload these yet. Well, we went to overdrive solenoid. That was our issue, right? Well, we would always hit no right here for a data stream. When you turn it on, it only turn on for a second, then it would turn off. Well, to use the scan tool to turn it on and off, you just go to overdrive solenoid, say you want a data stream, and just pick one PID. It don't matter what PID you pick. Let's just pick, I don't know, one. I do want to pick one, but it doesn't matter what you pick. Where in the heck is the one I'm looking for? Oh my gosh, I can't find it now. It's the transmission EATX one. Where is it? I was using my other, there it is. So I'm just gonna pick one. So when you toggle it now, if you have the scope hooked up with the set of live data, you were to scope it, you would toggle on, toggle off, toggle on for a second, toggle off, toggle on for a second, toggle off. Only when you have the live data pulled up. When you don't have it like that, so in the earlier part of this video, or part one of this video, however upload it, that's kind of one thing we had an issue with, is trying to, like, if we'd turn on for a little bit, when we had no live data for like a second, it would turn off. Well, we weren't catching it correctly for the overdrive one. Computer ended up still being bad because of that circuit in there. I believe a cracked solder joint or something in there. But I don't know if it's an Altel thing or a Chrysler thing or whatever the heck it is thing, or VW, I don't know. But you have to have a PID pulled up, parameter ID, to be able to toggle it and scope it correctly. Which I'll show in the next part of this video when I show some scoping stuff. I guess I'll go ahead and scope it. I'll scope the old one, you know, put it back in, scope the old one, compare to the new one and what it's doing. And I can show you that in the video next. Alrighty, so what we're doing now is we got the old computer in. We're back probably at the computer from, which is pin 1, or on the other side it's pin 19, going to the overdrive solenoid. The other scope lead going to battery ground. We're going to pick a PID in the active test for the overdrive, and we're going to go to the limp in status. So right now, it's not set for limp in status, which is good. If you go to the scope, you got your 12 volts. It's doing its checks right there. There's a check. It does it every 10 seconds roughly. We're going to go to F1. Turn it. It's going to toggle it on and off for a second. But it should be a solid, right? There's a dead spot there. Some weird crap there. A dead spot there. A dead spot there. See how erroneous it looks there? That's a good one. That's a good one. And there's a good one. And if you look, we're still not set on this. Now, if I was to put this thing in drive and gear and get above 1,000 RPMs, which I'm going to right now. Of course, it's going to change and do all kinds of other stuff, like right there. And if I go back, escape out of this where it's not actuator running, then I go back into the scope, because I went out of that bidirectional control. It's doing self-test, but if I put it in drive, it's going to do some stuff right there, because now the computer's not controlling for a second. It's the engine computer, tranny computer controlling it. Right there, it's doing its stuff. It's pulsating and stuff. Turning overdrive solenoid on and off when it wants to. So that's the bad computer. And now we're going to put the good computer in and show you that next. All right, so now we got the new PCM in. The one we wrote the VIN, the odometer, all that stuff. There, it's doing its self-test. So I'm going to go back and go to overdrive solenoid control. I want live data. I want the ETAX, which is electronic transaxle assembly, electronic assembly transaxle assembly, or something like that. You have to look up the acronym. But it's going to do its self-checks again, like every 10 seconds, like I said. You got alternator voltage there, right there. So we're going to go and pull our ETAX pit up. And it should say not set. Not set. We're going to turn it on. We're going to go to the scope. Now, if you look at this one's solid the whole entire time. The whole entire time it's solid. Before, a little bit ago, I showed you the bad computer. It would have little breaks. It had all kinds of weird checks it was doing. All that stuff. So this is a good one. And before, the old computer, you would move it. You would tap on it lightly. It would do all kinds of weird shit, go to set. This one, you can tap on it. You can smack and move it around. And this one's good. So now, if I go into this and escape out of this so the computer controls it, and I put it in drive, now it's back, but once in a while you'll see some stuff. It'll just do its self-checks, because it's not really using the overdrive only when it needs to. The other one was doing all kinds of weird shit even at this part. So, and if you go back to live data, once that pulls up, we'll pull that up. But the old one, well, I'll show you here once this thing pulls up. All right, so now if I pull up live data and I look at limp status, and I look at gear, I know we didn't show this on video, but yeah, I got to get limp status pulled up. So the old computer, you would drive it, you'd hit bumps, you'd do stuff, it would say set. And then when you put it in gear, drive, it would say third gear, because it would be stuck in gear the whole entire time. Stuck in third gear. The new good computer, no matter what we do, it's all good to go. You can rev it up, smack it around, do all that stuff, it's all good. So this car needs a new ECM, which is the PCM and TCM in one. Believe there's a wire, or not a wire, a circuit, a ground circuit, the control circuit for that pin in the computer. That is bad. It's causing all these issues. All right, so obviously we're going to put the new computer back in, or the salvage one, after we already programmed it, did all that stuff. We're going to go take it for a test drive and make sure it's all good to go next. All right, so everything's good. Like I said, everything's programmed. VINs wrote, key transfer data is done. Got the module in. All that stuff's done. Odometer's written. And I've been driving it for about 25, 30 miles now. upshifting, downshifting, no issues at all. Before, it would always be stuck in third. It would never get out of third. When you start off, it'd be in third. When you were driving, it'd be in third. All the, you know, the engine light would be on, all that stuff. I've been driving it, like I said, 25, 35, or 25, 30 miles so far, and everything is good to go. So what we're gonna do now is one last system scan, check fluid, just to make sure that's all good, and that'll be it. All right, so sun finally came up again. Been working on this thing for a while. I'm driving again to let it sit for like a couple hours. Now I'm driving again, and everything so far so good. You look here, the downshift here. Target gear in the bottom is first. Present gear is first. ETAX, which is electronic assembly, transaxle assembly, or something like that. It's not set. When it goes in the limp mode, it would say set. It would be stuck in third gear. But everything's working good. There's first, there's second, then third, fourth, fifth, or fourth, and then downshift because I let off the gas, back to fourth. Now it's going to go to fifth. But all that stuff's good. And just to show you here, make sure there's no codes, because we probably drove in it almost 30, 35 miles now. No codes. So what I'm going to do now, get it good and warm, the transmission temp, and check the fluid, make sure the color doesn't smell bad and the level is correct. All right, so no codes, everything's shifting fine still for the second. Well, actually it's my third test drive now, but I didn't film all that. It's running great. So I'm going to check the tranny fluid. So this tranny fluid, you pop this cap off, and there's what it is. It tells you on here, for dealer use only. So let me show you what you got to do. So what you got to do is you got to have a special dipstick that's laid out in millimeters, 20, 30, 40 millimeters. Look at this sheet. We got a Volkswagen Routan, which is a Chrysler Dodge Jeep transmission dipstick tool, 62E. We're going to use chart C, 11 to 9, 9 to 11, or a 10. So it tells you basically remove the cap, warm it up, you know, apply the parking brake, go through all the gears, let it sit there, which we already did all that. Chart C, we want to look at our temperature. So if, for example, well, let me just go show what our temp is. So while it's running, I got the scan tool pulled up. Our temp's 140 degrees for the thermistor for the trans temp. So on chart C, 140 degrees is right there. So you got your min and your max. So 140 degrees, you go up and you go over. You're looking at minimum of 20 millimeters to a maximum of 36 millimeters. So I'm going to be between 20 and 36 millimeters, which we're going to check next. So you take this long dipstick here, you put it in that hole, and if you look, if it focuses here, we're like between 20 and 30. The center line's 25, so we're probably like 26, maybe 27 millimeters. So I'm trying to film and do this at the same time. So we're about 27 millimeters. So if you look, 24 to 28, so let's just split the difference roughly. Move over. We're at 140 degrees. 140, 27. So we're right in the middle. Yeah, 140, 27. So we're right just below the middle half, right down in there somewhere. So that fluid's good. The fluid's red. It looks good. It doesn't smell bad. No metallic particles in there, nothing. So that is a good fix. There's a bad ECM, which the PCM and TCM is part of that on this 2010 Volkswagen Routan, which is the same thing as the 2010 Chrysler Town & Country or 2010 Dodge Grand Caravan, all with the 62 TE transmission. The overdrive solenoid control circuit in the TCM, I believe it's a cracked solder joint, but that is it for this vehicle. I know I said that's it, but I just want to show you that the tranny fluid is good. It's kind of hard to tell, but that it's a red there. It's red. This camera really doesn't do any justice. Let me get another sample here. So you can see it there, it's red, pretty red. So that's good, not brown, it's red, no metallic particles in there. So that is a good fix, again, for this 2010 Volkswagen Routan with the 3.8 liter engine and the 60